So today we're going to talk about the side, and side angle side theorems. And I should see a whole bunch of hands raised and go, hey, don't we already have side, and side angle side theorems? Correct. However, you have a side, and side angle side congruence theorems. These are the side, angle side similarity theorems. Okay? We are no longer going to be looking at these to see if these sides are congruent to each other. We're going to see if these sides are proportional. So, the side theorem says, if the corresponding side lengths of two triangles are proportional, then the two triangles are similar. So, this one says, corresponding sides proportional, therefore the triangles are similar. Therefore, yes. Math shorthand. Well, 3 dots that are in a triangle like that is therefore. 3 dots like this mean because. The side angle sides theorem says, if you have 2 sets of corresponding sides proportional, and the included angle is congruent, then the triangles are similar. So the side angle side says I've got 2 sides proportional plus the angle's got to be in between those 2 sides that are 2 sets of sides that are proportional. So again, the gist of today is if the sides are proportional in one of these 2 relationships, you can tell me the triangles are similar. If I tell you that the triangles are similar, that means you can set up a proportionality statement to find the missing sides. And Kylie's just smiling. So please look on the bottom of page 383. I want you to look at those 3 triangles, why I draw them on the board, and I want you to tell me which pair of triangles are similar. So again, reminder, the smallest sides match the smallest sides. The biggest sides match the biggest sides. That means the leftover sides have to meet the leftover sides. Step 1 was to determine which triangles are proportional to each other. So what you want to do is you want to set up the ratios of small to small, big to big, middle to middle to see if they're all the same. So let's do small, medium, and big for this pair. Okay, so 20 over 24. Is that the same as 26 over 33? And is that the same as 24 over 30?
Mr. Taylor?
Yes?
Can you please send answer that to the office?
Yes.
Thank you.
So put these 3 in the calculator and tell me whether or not you get the same decimals. Put these in the calculator, see if you get the same decimals. And then I'm going to do the same thing here. And here. So I'm going to call this A, B, C. So this first group is A to B. The second one is B to C. And the third one is A to C. So what I want to do is I'm matching every pair of triangles together. I check to see if all three sets of corresponding sides give me the same proportion. And if all three sets of corresponding sides give me the same proportion, then those two triangles are similar. Just type this stuff in the calculator. Okay. So do this group, you're going to get 2/3 for every single one of them. So you know triangle A is proportional to triangle C. This one is going to be 5/6. This one is going to be 5/6. Because some of you, and this one, is this one 5/6? What's 5/6 is the decimal? So 5/6, about 0.833. So that one repeats. 26 divided by 33 is 0.78 repeating. So these are not proportional. So 24 over 30 is 4/5. 33 over 39. Big honkin' decimal. This is 0.8. This is 0.846. I can stop now and say that those two are not proportional. Or they're not similar. So we found out which two are similar to each other. So the next step says to write a similarity statement. So I'm going to put these in alphabetical order. What's the first letter in alphabetical order there? L. What's the next letter? What's the next letter? So what I need to do is, this triangle doesn't mean anything. I need to match the L in this triangle with whatever letter it matches with in this triangle. What letter does the L match with? Y. What letter does the M match with? And the N matches with? So that would be the similarity statement for that problem on the bottom of the page. Any questions on that one? So basically what you need to do is you need to set up proportionality state. You need to set up all the ratios and see if they're the same. Because that's what it means for things to be similar, is all the ratios of the matching side pieces are the same. You're going to need to, unless you can do this work in your head. Now it's guided practice 1. So for guided practice 3 and 4, they want us to tell why we are able to say that the two triangles are similar to each other. So the only ways we have to say that two triangles are similar to each other is using the angle-angle postulate, where two angles of one triangle congruent to two angles of another triangle, then the two triangles are similar. Or using the side-side-side or side-angle-side similarity theorems. So those are the three possible answers we have here. So it wants to know if SRT is similar to PNQ. Well, I either need three sides. Do I have that? Yes or no? Do I have three sides that I know the lengths of on both sets of triangles? Do I have two angles that I know in both sets of triangles? I only know one of them. I'm doing number 3 right now. So the only option that's left over is going to be that one. Do I have two sides and an included congruent angle? Yes, I do. It's two sides and an included congruent angle. So to prove that they are, I can use side angle side, I need to do the corresponding sides to check their ratios. What I need to know is left over left. Is that equal to bottom over bottom? What's 24 over 18? Calculators, please. Okay. What's 28 over 21? Are the same as each other. So what you can do is you can say that the corresponding sides are proportional and the included angle is congruent, therefore you can use side angle side. Just because they give you the side angle side setup doesn't necessarily mean in your homework or a quiz or a test that they are going to be similar triangles. You actually need to check those ratios. This one looks like a big honkin' mess. So step one is to draw both of these triangles in the same orientation. We were lucky here. They gave them the two triangles in the same orientation. So I want to draw a triangle XZW. That's, whoa. I got two X's. Let me guess, that's a Y?
Yeah, that's a Y.
Okay. I want to draw a triangle XZW. So I'm going to keep it in its same original orientation. And that's 12, 16, 20. Then it says to draw a triangle YZX. Notice that if they want to be similar, the pieces have to match up right. So I'm going to draw it in the same orientation. And notice here I went XZW. I went top, bottom right, then bottom left. So I have to do the same here. Y, Z, X. And I'm going to fill in the missing side links that are here. Y to Z is 9. Z to X is 12. And X to Y is 15. I'm just matching up the pieces. I just redrew this triangle, rotated. I took this triangle right here and rotated it. But I need to make sure that, so I put the Y on the top because it needs to match with the X. You want to draw them in the same orientation with the corresponding parts next to each other. So, what I have here is I got three sets of sides. And if all three sets of sides are proportional, which theorem will I use? Side, side, side. Do I need to use all three sets of sides necessarily? If these two sets of sides that I have left remaining are proportional, which theorem can you use? Side angle side. So there are two possibilities here. If all three sets of corresponding sides are congruent, you can use side, side, side. Or if you only want to check two of them, you can use side angle side. So there may be two possibilities here. So let's do hypotenuse over hypotenuse. Compared to right over right. Compared to bottom over bottom. And hopefully, when you guys put this in the calculators, you all get 1.3 repeating for every single one of them. So the answer to this guided practice would be either side, 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 or side angle side, whichever one you wanted to do. You could actually use either theorem. So, on these problems, I'm going to write down some generic steps for you. How's that sound? Today is the 11th. Redraw each triangle in same orientation. That step is not required, but it really, 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 really helps you set things up. The way you're going to be able to tell the same orientation is either you are going to match letters from a similarity statement. For example, triangle ABC is similar to triangle DEF. If this was A, B, C, the one I drew in this orientation, the A has to match with the D, the B has to match with the E, and the C has to match with the F. So you're either going to match the letters from your similarity statements, or smallest side to the smallest side, the biggest side to the biggest side, and the leftover side, yes, with the leftover side. And once you do that, either matching the letters or matching the sides up, you are going to check corresponding side ratios to see if the same. Or if they tell you they're similar, that you're going to be able to solve for a variable because you're going to be able to set those ratios up to be the same. So all you're doing is you're setting up proportions just like you were doing in 6.1, 6.2, and 6.3, but now you have some different facts that let you set up these proportions. And again, this is the biggest help here. Redraw the triangles. Get them facing the same way and match the things up. And then it's just talking to yourself in words.
It's 125.
Mm-hmm. Maybe. Any questions on that?